to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of lines using the Solid Edge software. Coming to the problem statement. A line PQ 85 mm long has its end P 10 mm above the HP and 15 mm in front of VP. The top view and the front view of the line PQ are 75 mm and 80 mm respectively. Draw its projections and determine the true and apparent inclination with HP and VP. So after having read the problem statement, we can do the analysis of the problem statement. So we can conclude that the data given to us is the endpoint P location is given, that is, it is 10 mm above HP and 15 mm in front of VP. So this is the first point. The second point is the true length of the line is given to us, which is 85 mm, and also the measurement of this length of the line in the front and the top view is also given, that is 75 mm and 80 mm in the top and the front views respectively. So, however, we haven't mentioned about the details of the apparent inclinations or the true inclinations. So here the length, true length is given and the apparent length in both the planes is given. So keeping this data, we need to measure what is the true inclination and also the apparent inclinations with respect to HP and VP. So we'll see how to solve this problem. So we'll begin with drawing the XY line by selecting the line command. The thickness should be 0.18 mm. So we will draw a line of any arbitrary length and annotate this line as XY, which is the reference line. The plane above the reference line is the vertical plane VP and the plane below the reference line is the horizontal plane HP. So we will locate the point P in the first quadrant. So by selecting the projector line of thickness 0.13, so the point P is 10 mm above the HP. So 10 mm above the HP will record the front view of the point, that is P dash, and 15 mm in front of VP. So we'll be recording the top view at a distance of 15 mm in front of VP. So we can just show the dimension of the location of the point P of the line PQ. So from this point, we shall draw the locus of the point P in the horizontal and the vertical planes. So we'll draw the locus of the line which is parallel to the XY line. So now we shall annotate this particular line as the locus of P. So this is the locus of P in the vertical plane, and this is the locus of the point P, locus of point P in the horizontal plane. So now we shall mark the length that is given to us. So we cannot measure the true length because the true length is 85 mm, but we do not know the true inclination. So with this data, we cannot just randomly draw the true inclination of the line. So we need to first mark the apparent length, that is the front and the top view lengths of the line PQ. So how can we locate that? So first we'll annotate the point P here. So this is P prime or P dash, and this is the point P, the top view of the point P. So now we will take the line option and then select a continuous line of thickness 0.13, and we do know that the front view of the line is here. So the true length is 85 mm, but we will consider the apparent length that is given to us. So the front view of the line is 80 mm as per the given data, and the front view is in the vertical plane. So first we will draw the vertical plane, the line in the vertical plane of length 80 mm. So this point is what? It is P dash and Q2 dash. And next we will draw the top view of the line which is in the horizontal plane, and the top view measures 75 mm as per the problem statement. So let me draw a line of length 75 mm, and this end point is nothing but Q1. So this is the top and the front views of the line. So keeping this in mind, I will draw a vertical projectors, and from the end point Q2 dash, I will draw this vertical projector downwards. So the point here is I'm just trying to do the reverse procedure. So now what I'll do is I will locate the locus of the point Q by taking the data that is given to me, telling that the true length of the line is 85 mm. So what is that I can do? I can go for the arc by center point and keep the point as P dash and cut an arc of radius 85 mm intersecting the line that we have drawn. So select the line option and arc by center point. Keep the center point as P dash and cut an arc of length 85 mm radius. So we do know that the true length is the same in both the planes. So keeping this data in mind, so I'll be intersecting like this, the locus line. So now let me join this point of intersection. So this is 85 mm and let me draw the locus line of the point Q here. Select the dotted lines and from here I'll be drawing a line parallel to the XY line and this becomes the locus of point Q. So this point is Q1 dash and similarly here in the horizontal plane I'll select the line option. The endpoint is P and I'll be drawing a line of true length 85 mm. It should be a continuous line. So this point is Q2. So PQ2 and P dash Q1 dash are the true length of the line, that is PQ 85 mm when inclined at an angle. So that angle we need to measure. So that is what is asked in the problem statement. So now let me complete the procedure for drawing the apparent lengths also. For that again let me select the line option, select a continuous line. So first we will draw the locus of this point Q2. So this is the locus line of Q2. So select a continuous line of thickness 0.13 and again select arc by center point and we'll repeat the procedure. So P dash to Q2 dash and then cut an arc and similarly P dash to Q1 dash and then cut an arc to intersect the locus. So I'll just use the trim option and trim this so that it is not getting confused with the actual arc that we require. So we'll select the line option again and we will draw the apparent lengths. So you can just see that this is the point of intersection. So it is exactly 75 mm as given in the problem statement. That is the top view of the line PQ, and then this is the front view of the line PQ, which is 80 mm. So I'll select this point and annotate this point as Q dash, and I'll annotate this point as Q. So this is the procedure to draw the orthographic projection of a line when its true length and the apparent lengths are given in both the front and the top view and without any details of the apparent and the true inclinations. So now we can measure the apparent and the true inclinations. So to avoid the confusions, let me just trim the unnecessary lines. So we will indicate the leaders. So the first procedure was we mark the front view of the line, that is P dash Q2 dash, and then drew the projector in the downward direction. So I'll indicate the direction as downward. And then we mark the top view of the line PQ, that is PQ1, and from here we drew a projector upwards. So let me mark the direction like this, correct? And after this, what was the condition? The arc was drawn in this direction, that is the counterclockwise direction, and here the arc was drawn using the clockwise direction. Okay, so this is the procedure. So now what we can do is we can just measure the angle. So PQ1 dash and this locus line gives me the true inclinations, true length of the line, and this particular angle gives me the value of theta and phi. So theta is 28 degrees and the value of phi is 20 degrees. And now we'll measure the apparent inclination. So the apparent length and then the reference plane, the apparent length and the reference plane. So 30 degrees and 23 degrees are the values of alpha and beta. So these are the apparent inclinations and these are the true inclinations. So to verify, this is 80 mm, which is the length of the line in the front view, and this is 75 mm, which is the length of the line in the top view. And also this line is 85, which is the true length of the line in both the front and the top view. So we can just annotate this line also. So this is locus of Q in the vertical plane, and this line is locus of Q in the locus of Q in the horizontal plane.